In this question again, we've got a decay question because we've got a minus k. So radioactive substance minus k m0 e to the minus kt. So we want to find m0 and k. We've got 200 kilograms decaying to 195 kilograms after 10 years. So if initially it's 200, we do a substitution, we get m0 being 200. So it's not too bad because we know it's initially. And then after 10 years, it's 195. So sub 195, the m0 is 200 minus k times 10, divide by 200. Use our definition of a logarithm to get minus 10k equal to the natural log of 39 on 40. So k is equal to minus 1/10 of natural log of 39 on 40. You could use that. You could put it as positive 1/10 of natural log of 40 on 39 if you want when you do your substitution. Doesn't really matter. Just make sure you're careful of all your signs. B, we want the mass after 15 years then. So when t is 15, we do our substitution. So the minus k times 15 gives us 3 on 2, natural log of 39 on 40. Realise that that's going to be a negative, so it's still going to be decaying. So it should be less than, should be 192.55 approximately. And the rate of decay after 15 years. So what's the rate will be the minus k times 200 e to the minus kt, because we derive it. So after 15 years, there's our value of k that we've had before and what we had in the last question. So last part of the question. So when we do that calculation, it should come out, because it's in kilograms, it should come out as 0.487, or if you write it as 487 grams per year. We can keep it in kilograms per year if you like. The half-life of the substance. Now some of you doing chemistry or physics might do some half-life and understand that term, but basically half-life of a substance, how long does it take it to be half of what it was? So the time taken to decay to half its mass. So for the 200 become 100, how long does it take? Well, again, we do our definition of our logarithm. So the minus 1 on k, natural log of a half. So remember, we've had the value of k all the way through, substitute that in, and we get 274 years approximately.